Assalamualaikum warahmatullahi wabarakatuh. We are from group P10. Today we will presentation about sampling, design and procedures and sampling, final and initial sample size determination from Malhotra's book, and the last one is index number from the Gibson's book.
My name is Alka Qudriyya R. My person's number is 4.
My name is Fahmi Mahmuddin S, and my present number is 14.
My name is Indah Permata A. My present number is 19.
Hello, my name is Pinkan Saladina N and my present number is 35.
Sampling, design and procedures. Sampling is one of the components of a research design. The formulation of the research design is the third step of the marketing research process. At this stage, the information needed to address the marketing research problem has been identified and the nature of research design. Sample or census. The goal of most marketing research projects is to obtain information about the characteristic or parameters of a population. Population is an aggregate of all elements that share some common characteristic and which form the whole field for the purpose of marketing research. Population parameters are usually numbers. Information about population parameter can be obtained by taking a census or sample. To better understand the comparison of sample and census, here is a comparison table for their use. In budget, sample is small, census is large. Time available, sample is short, census is long. In population size, sample is large, census is small. Inference in the characteristic, sample is small, census is large. Cost of sampling errors, sample is low, census is high. In cost of non-sampling errors, sample is high, census is low. Nature of measurement, sample is destructive, census is non-destructive. Attention to individual case, sample is yes, census no. The sampling design process. There are 5 steps in the sampling process. First, define the target population. Sampling design begins by specifying the target population. The target population is the collection of elements or objects that process the information solved by the researcher and about which inferences are to be made. Defining the target population involves translating the problem definition into a precise statement of who should and should not be included in the sample. Second, determine the sampling frame. A sampling frame is representation of the elements of the target population. It consists of a list or direction for identifying the target population. In determining the sampling frame, generally a researcher must be able to recognize and handle sampling frame errors. Third, select a sampling technique. In the Bayesian approach, elements are chosen sequentially. After each element is added to sample, data is collected, sample statistics are calculated, and sampling costs are determined. In traditional sampling, all samples are selected before data collection begins. Fourth, determine sample size. Important qualitative factors that must be considered in determining sample size include the importance of the decision, the nature of the study, the number of variables, the nature of the analysis, the sample size used in similar studies, the level events, completion rates, and resource constraints. Last step is execute the sampling process. Execute the sampling process requires detailed specification on how the sampling design and decisions relating to population, sampling frame, sampling unit, sampling technique, and sample size must be implemented. A classification of sampling technique. Non-probability sampling technique. Convenient sampling. Convenient sampling seeks to obtain convenient sample elements. The selection of the sampling unit is left to interviewer. Often, respondents are chosen because they are in right time and place. Judgmental sampling. It is a form convenient sampling where the population elements are chosen based on the researcher's judgment. Researchers have the expertise to incorporate elements into the sample. Quota sampling. Quota sampling can be seen as two restricted judgmental stage. The first stage consists of developing a control category or quota from the population element. In the second stage, the sample elements are chosen based on comfort or judgment. Snowball sampling. Snowball sampling, the initial group of respondents is usually randomly selected. After the pre-interview process, respondents were asked to identify other people who were included in the target population. Probability sampling technique. Simple random sampling. In simple random sampling, each element in the population has a known and equal selection probability. Furthermore, every possible sample of a certain size has the sample probability of being the chosen sample. Systematic sampling. In systematic sampling, samples are taken systematically by a random initial process. The systematic sampling technique is similar to the simple random sampling. Stratified sampling. Stratified sampling is the process by which populations are grouped into specific subpopulation or strata. The element random samples are chosen like the SRS technique. Sequential sampling and double sampling. In sequential sampling, the population elements are sampled in sequence. In the double sampling, the first phase is sample is chosen and some information is gathered from all elements in the sample. In the second phase, subsamples from the original sample and additional information are obtained from the elements in the subsample. Internet sampling. Issues in online sampling. Internet surveys offer many advantages. The respondent can complete the survey at their convenience. Online sampling technique. In online sampling technique, visitors to a website are intercepted and given an opportunity to participate in the survey.
Chapter 12. Sampling. Final and initial sample size determination. To understand the statistical aspect of sampling, it is important to know the basic definition and symbols. There are 6 symbols. Number 1. Parameter. Parameter is a summary description of a fixed characteristic or measure of the target population. Number 2. Statistic is a summary description of a characteristic or measure of the sample. And 3. Finite population correction. Finite population correction is a correction for overestimation of the variance of a population parameter. Number 4. Precision level. Precision level is the desired size of the estimating interval. Number 5. Confidence interval. Confidence interval is the range into which the true population parameter will fall. And the last one is confidence level. Confidence level is the probability that a confidence interval will include the population parameter. The sampling distribution. The sampling distribution is the distribution of the value of a sample statistic compute for each possible sample that could be drawn for the target population under a specific sampling plan. An important task in marketing research is to calculate statistics, such as the sample mean and the sample proportion, and use them to estimate the corresponding true population value. This process of generalizing the sample result to the population results is referred to as statistical inference. Statistical approach to determining sample size. The statistically determined sample size is the net or final sample size, the sample remaining after eliminating potential respondents who do not qualify or do not complete the interview. The statistical approach to determining sample size that we consider is based on the traditional statistical inference. The confidence interval approach. The confidence interval approach to sample size determination is based on the construction of confidence intervals around the sample mean or proportion using the standard error formula. Sample size determination means the approach used here to construct a confidence interval can be adapted to determine the sample size that will result in desired confidence interval. Sample size determination proportion If the statistic of interest is a proportion rather than a mean, the approach to sample determination is similar. Multiple characteristics and parameters. In the preceding examples, we focus on the estimation of a single parameter. In commercial marketing research, several characteristics, not just one, are interested in any project. The researcher is required to estimate several parameters, not just one. The calculation of sample size in these cases should be based on consideration of all the parameters that must be estimated. Other probability sampling techniques. The determination of sample size for other probability sampling techniques is based on the same underlying principles. The researcher must specify the level of precision and the degree of confidence and estimate the sampling distribution of the test statistic.
Adjusting the statistically determined sample size. The sample size determined statistically represents the final or net sample size must be achieved in order to ensure that the parameters are estimated with the desired degree of precision and the given level of confidence. And in order to achieve this final sample size, a much greater number of potential respondents have to be contacted. Incidence rate refers to the rate of occurrence or the percentage of persons eligible to participate in the study. Similarly, the determination of sample size must take into account anticipated refusals by people who qualify. The next one is calculation of response rates, and the formula is response rate is number of completed interviews per number of eligible units in sample. Non-response issue sampling. The two major non-response issues in sampling are improving response rates and adjusting for the non-response. Non-response error arises when some of the potential respondents included in the sample do not respond. The next one is non-response issue sampling. The first one is improving the response rate. The primary causes of low response rates are refusals and not at homes. Refusals is which results from the unwillingness or inability of people included in the sample to participate, result in lower response rates and increased potential for non-response bias. The second one is adjusting for non-response. Subsampling of non-respondents. Subsampling of non-respondents, particularly in the case of male surveys, can be effective in adjusting for non-response bias. In this technique, the researcher contacts a subsample of non-respondents, usually by telephone or personal interviews. The next one is adjusting for non-response. Adjusting for non-response is replacement. In replacement, the non-respondents in the current survey are replaced with non-response from an earlier. The researcher attempts to contact these non-respondents from the earlier survey and estimate and administer the current survey questionnaire to them. The second one is substitution. In substitution, the researcher substitutes for non-respondents other elements from the sampling frame that are expected to respond. The third one is subjective estimates. When it is no longer feasible to increase the response rate by subsampling, replacement, or substitution, it may be possible to arrive at subjective estimates of the nature and effect of non-response bias. International marketing research. When conducting marketing research in foreign countries, statistical estimation may be difficult because estimates of the population variance may be unavailable. If statistical estimation of sample size is all attempted, it should be realized that the estimates of the population variance may vary from country to country. It may be a mistake to assume that the population variance is the same or to use the sample size in different countries. One is ethics in marketing research. Although the statistical determination of the sample size is usually objective, it is nonetheless susceptible to ethical concerns. Ethical dilemmas can arise when the standard deviation is estimated honestly.
Chapter 6 Index Number, Gibson's book. The index number represents a comparative value of gradual change expressed in the form of another representation. The index figures are used to compare a change from period to period, taken into consideration by the way it calculates. The number of the index is divided into two, which is the digit of the index of error and the aggregative index number.
Relative index numbers. Relative index numbers are used if we want to see changes to the condition of a commodity of various periods. In this case, our only concern is one commodity. Relative price index formula is I equals Pn per P0 multiples by 100. I is for relative price index, Pn is the price of the working period, P0 is the price of a basic period. Note, if more than one commodity could also be looked up to the average index of relativity follows I equals sigma Pn per P0 per K. K is for the number of commodities. Index are usually used where all commodities may be equally important. In the simple aggregative index numbers, emphasis review given at price value, thus being known as a simple aggregative price index and a simple aggregative quantity index. First is simple aggregative price index or IP. Simple aggregative price index formula is IP equals sigma Pn per sigma P0 multiples by 100. IP is for N period for price index, Pn is price of the working period, and P0 is basic period prices. A simple aggregative number index. A simple aggregative number index is proved IQ equals sigma Qn per sigma Q0 multiples by 100. IQ is for N period for quantity index, Qn is for quantities of working periods, and Q0 is for quantity of rudimentary periods.
Index weighted aggregate. General formula. Weighted aggregate price index. I equal to sigma PNW divided by sigma POW multiplied by 100 with W is weighting. Relative price index. I equal to sigma PN divided by QO multiplied by W divided by square root W multiplied by 100. Last payers index numbers. Last payers price index. The last payers price index is obtained through the formula sigma PNQO divided by sigma POQO multiplied by 100 with the information as follows. Last pairs quantity index. The last pairs quantity index is obtained through the formula sigma POQO divided by sigma POQO divided by sigma POQO multiplied by partial price index. The partial price index obtained through the formula sigma PNQN divided by sigma POQO divided by 100. Partial quantity index. The partial quantity index is obtained through the formula PQ equal to sigma PNQN divided by sigma POQO multiplied by 100.
Index in sequence. The formula is IA is sigma PNQO per sigma POQO times 100. After that, to calculate the index in sequence, the formula is 100 times IA per 100 is index in sequence.
Real wage, and with the wages per year and per person is 600,000. With the living cost is 100 and the real wages is 600,000. And in year 2 there is 6 470,000, with the living cost is 150 and the real wage is 667,000, and the year 3 is 700,000, for the living cost is 155 and the real wage is 583,645,000. Directions. In view of year 1 to year 2, although the salary has gone up, wages have actually decreased because the increase in the cost index exceeds the salary increase and thus the purchasing power has decreased. And second, in the year 2 to 3, it turned out to be an increase in the wages of money. So it should be 700,000 minus 670,000 per 670,000 multiplied by 100 equals 4.47%. It's bigger than the increase in the cost index and therefore the purchasing power goes up. Increase in the cost index, 155 minus 150 per 150 equals 100. Multiples by 100 equals to 3.33%. This could be used as inflation measures from year 2. Then the productivity of the current period is 400 chairs per 800 chairs equals 0.5 seats per hour of labor. Then suppose 1,000 labor hours produce the same output, or 400 seats in their period. Then basic period productivity is 400 chairs per 1,000 chairs equals 0.4 seats per hours of labor. Or from the two calculations above, the productivity index can be calculated. I equals productivity of the current period per basic period productivity multiples by 100 equals 0.5 per 0.4 multiples by 100 equals to 125. From the results obtained, the increase in productivity between the current period to the base period is 25%. It's time to practice chapter 6. Number 1, answer is A, 0, Z 0.025 equals to 1.96. It means in the table Z, that is the value of the intersections between rows 0.002 with the column 0.005. And B, the question is T 0.05.4 equals to 2.13 is the meaning of in the table T, the value of the intersections between row 4 and column 0.05.
Number 2. Make a confidence interval of 90% for the average population of bottled water. The answer is X bar equal to 40 F480. Alpha is 0.1, Z 0.5 equal to 1.64, sigma equal to 1.8 and equal to 8. Then the confidence interval for mu volume of water is 478.956 is less than or equal to mu is less than or equal to 481.043. This means that with 90% confidence, the average volume of bottled water is between 478.956 to 481.043. 0.043.
Number 3. The answer of questions number 3 is A. 60 minus in parentheses 2,33 times in parentheses 10 per 7 less than equals mu less than equals 60 plus in parentheses 2,33 times in parentheses 10 per 7. With a confidence of 98%, the average sales of products in the region is between 56,672 less than equals mu less than equals 63,328. B. The company's total sales interval is 80,628.
Number 4. So the answer is we need to know the meaning of the formula. There is a symbol for N, E, and sigma. N is required sample size, E is the large tolerated error, and sigma is population deviation standard. The formula is N equals Z alpha per 2 sigma per E square 2 square 2 multiplies by sigma equals to range per 4. So the way is we already know that the E is 3 and the sigma for population deviation standard is 60 minus 10 per 4, which is the answer is 12.5, and the alpha per 2 equals 0.05. So Z is the 0.05 equals 1.645 equals to 1.65. The N is 1.65 multiplies by 12.5 per 3 squared 2 is equals to 46.24 equals to 47 samples. So we've got the answer is the 47 sample.
Number 5. The answer is N equal to 15, X bar equal to 12, alpha equal to 9.05, V equal to 14, S squared is equal to 9.6, S is square root 9.6 equal to 3.09. Then the confidence interval is 10.288 is less than or equal to mu is less than or equal to 13.711.
Number 6. Make a 95% confidence interval for the difference in average time between the old and new methods with the assumption that the population variants are both the same. And the answer of number 6 is the confidence interval is 50,645 less than equals mu1 per mu2 less than equals 49,648.
Answer for A is x1 average min x2 average plus minus z alpha per 2 square root of sigma 1 square 2 per n1 plus square root of sigma 2 square 2 per 92. You can write like 46.8 minus 49.4 plus minus z 0.025 square root of 9.5 square root 2 per 10 plus square root of 9.5 square root 2 per 10 equals mean 2.6 plus 1.96 multiplies by 134.35 equals to minus 265.93 smaller than mu1 min mu2 smaller than 260.73. Answer for question B, SP equals square root of n1 min 1 multiplies by s1 square 2 plus n2 min 1 multiplies by s2 square 2 per n1 plus n2 min 2. So we've got the square root of 10 min 1 multiplies by 9.06 plus 10 min 1 multiplies by 8.03 per 10 plus 10 min 2, and we've got the answer square root of 81.54 plus 72.27 per 18. So the answer is square root of 8.55 equals to 0.92. And then for a 95% confidence interval, we've got the x1 average min x2 average plus minus t alpha per 2 point v multiplies by sp multiplies by square root of 1 per n1 plus square root of 1 per n2, and you could write 46 point so for the 95% confidence interval is x1 average min x2 average plus minus t alpha per 2 point v multiplies by sp multiplies by square root of 1 per n1 plus square root of 1 per n2, and equals 46.8 minus 49.4 plus minus t 0.025.18 multiplies by 2.92 multiplies by square root of 1% plus square root of 1% equals min 2.6 plus minus 2.1009 square root of 1 per 5 equals min 3.54 smaller than mu1 min mu2 smaller than min 1.66. The answer for question C, we just made the table for the sample 1, sample 2, and the difference between sample and the sample 2, and we've got the differentiation, which is D in there is 2.6 and the SD is 329.804. So the formula is D T average plus min T alpha per 2 point V multiplies by SD per square root of N. Equals 2.6 plus minus T 0.025.9 multiplies by 329.804 per square root of 10. So we've got the answer is minus 233.3 is smaller than the mu d smaller than 238.5.
Number 8. The answer is alpha equal to 0.05, z 0.025 equal to 1.64, sigma is 1.46 and is 30. So the confidence interval for the telescope variant is plus minus 1.96 multiplied by 1.46 over square root 30. That is, the confidence interval for the telescope variant is 0.522 or minus 0.5224 is less than mu is less than plus 0.5524.
Number 9. Make a confidence interval for the proportion of dead mosquitoes. The answer is N1 is 1000 and X2 is 760 and N2 is 1000 and P2 is 0,760 from 760 over 1000 and X1 is 825 and P1 is 0,825 from 825 over 1000. Square root of P1 times Q1 per N1 plus P2 times Q2 per N2 is square root of 0,0825 times 0,175 over 1000 plus 0,76 times 0,224 over 1000 is 0,018 and the z is 0,01. Confidence interval P1 minus P2 is 0,065, 0,018 times 0,01 is 0,00018 and 0,065 plus 0,00018 is less than or equal to P1 minus P2 is less than or equal to 0,065 minus 0,00018 equal 0,06518 is less than or equal to P1 minus P2 is less than or equal to 0,06482. Number 10. The answer is P is X divided by N, and X is number of success from case of the center attention, and N is number of sample. If the number of N is large, N is greater than 30, then interval 1 minus alpha times 100%. For proportion is P plus minus Z alpha per 2 square root of P K divided by N. Method: N is 1000, X is 550, P is 550 over 1000 is 0,50. K is 1 minus 0,50 is equal 0,45. Confidence interval 95% is 0,50 plus minus 1,996 square root of 0,50 times 0,45 45 over 1000 equal 0,50.
Number 11. The answer is E equal to 9.02. Therefore, the minimum sample size required is, we use Slovene formula, N equal to N divided by 1 plus N E square. We get the N is 1250. The minimum sample size required is 1250.
Question number 12, and the answer of number 12 is the confidence interval is about 2,456 less than equals sigma squared less than equals 4,698.
Validity. This validity test is used to measure the validity of questionnaire used by researchers in measuring and obtaining research data from respondents. The research questionnaire is said to be of quality if it has proven its validity and reliability. Each valid question is R count value greater than R table value. In here, we use the results of a questionnaire from a study entitled The Role of Instagram at P2PTM Kemenkesri as a Health Campaign Media by Anissa Sekarwulan, Novita Hidayat Purwanto Jamil, and Dini Safitri. To test the validity, we use the SPSS application. This is the tutorial of it. Okay, if done, we need to go to data view and we can see that there's P1 until 10. In this research, we have 35 respondents, so we need to serve the original data from the questionnaire from each question. Here, then we select all and then we copy, and we paste it to the data view until 35 because we have 35 respondents. Okay, then we click analyze, scale, reliability analyze, and then Control A, select all of them, move to the items, and then click statistic, then click item, scale if item deleted, and then click continue, and the model is alpha, and then click OK. So here it is, we can see the output, and we can see the 35 data too. Here, if we need to test the validity, we can see it in the item total statistic in the corrected item total correlations. Here we have the word, so we can see if it's the same or not. Here, so we can see it. 500. Yeah. Yeah, we can see that it's clearly the same. So, okay. If we want to test the validity, we will use the product moment. So the product moment is using the principle of correlating between the scores of questionnaire items with the total score of respondents answered. Table R value of the data is seen from the alpha column where the number of respondents is reduced by 2 or degree of freedom. So 35 respondents mean 2, so the value of R ranks 33 with alpha of 0.334. Then it can be concluded if the R value is more than 0.4, so the data is valid. The valid data is the number 1, 2, 3, 4, 5, 7, 8, and 10. And the number 6 and number 9 is not valid because it's not more than 0.334. From the questions, we've got 8 items valid and 2 not valid.
Reliability. In this research, reliability measurement using the Cronbach-Alpha technique. This technique or formula can be used to determine whether a research instrument is reliable or not. The criteria for research instruments are said to be reliable using this technique. If the reliability coefficient greater than 0.6, data that is tested to determine whether or not a research is reliable is items valid data. From the result of the validity test previously, there were only 8 valid question items, so when testing reliability, we exclude 2 invalid items from a total of 10 questions. This is a tutorial of reliability test. Still using the data, first we click Analyze, Scale, and then we click Reliability Analyze. After that, we exclude or remove invalid question items. We see again in previously validity data, there is information can change behavior. We remove. Then there is often responding to information. We remove also. Model alpha. We click OK. And the output sheet appears. We see the reliability statistic table with Cronbach alpha 0.890 with a total of 8 item tests. So these 8 items of question or questionnaires are reliable because they meet the requirements, that is, the reliability coefficients greater than 0.6.
Univariate. This analysis is used for summarize the set of measurement results data in such a way so that the set of those data turns into the useful information. To do this analysis, we use the SPSS application. The data is still the same as we have used to examine the validity and reliability. First, we put the mean of the respondents' answers in value. For example, 4 means strongly agree. Put the 4 in value, then put the strongly agree in label. Next, 3 means agree, 2 means disagree, and 1 means strongly disagree. Click Add and then click OK. Do it in every questions, copy it, and then paste. If it's like this, then go to the data view, click Analyze, click Descriptive Statistics, then click Frequencies. We choose all of the questions by click Ctrl+A. Then move it to variable, then click OK. The summary of the data will appear. There are 35 respondents of each items, then there are the summaries of each questions. Instance, the first questions, there are 18 persons who agree, 17 persons who strongly agree, and the total is 35. Next, for the reliable information, there are 25 persons who agree and 10 persons who strongly agree. Next, for the information received as is, there are 6 persons who disagree, 20 persons who agree, 8 persons who strongly agree. Then move to information that makes us realize the importance of health. There are 18 persons who agree, 17 persons who disagree, and the total is 35. Information can affect while making a decision. There are 1 person who strongly disagree, 1 person who disagree, 26 persons who agree, 7 persons who strongly agree, and the total is 35. Move to information can change behavior. There are 4 persons who disagree, 27 persons who agree, 4 persons who strongly agree. For the information can attract attention, there are 28 persons who agree, 7 persons who strongly agree, and the total is 35. Consistent in telling the information. There are 24 persons who agree, 11 persons who strongly agree. And next, respond the information. There are 1 person who strongly disagree, 9 persons who disagree, 21 persons who agree, 4 persons who strongly agree. And for the last one, share the information to the closest persons. There are 2 persons who strongly disagree, 5 persons who disagree, 20 persons who agree, 8 persons who strongly agree, and the total is 35. And that's how to analyze the univariate.
Bivariate. Bivariate analysis is used to analyze data that has 2 variables in the research. This is usually done to see whether a variable, such as gender, has a relation with another variable or measure the relation between the 2 researched variables. We use the research entitled Hubungan Pengetahuan dan Sikap dengan Gaya Hidup Sehat Mahasiswa S1 Peminatan Promosi Kesehatan Fakultas Kesehatan Masyarakat Universitas Indonesia tahun 2009 by Karina Arfianti. The following are excerpts of her research. Here we only use the variable relation between sex and lifestyle. To do bivariate analysis, we use the SPSS application too. First, we open the application. After that, click the variable view. We type here jenis kelamin with no space. and then gaya hidup. Change decimal to 0. Fill in the variable with the variable that we want to connect. For the value column, there are two variables, gender and lifestyle. Gender variable divided by 2, 1 for male, 2 for female. In the gender variable, there are 1 for healthy and 2 for unhealthy. Next, enter to the value. 1 for male, 2 for female. Okay. 1 for healthy and 2 for unhealthy. To input data from respondents, we move to data view. Previously, we was made the data row in Excel, then copy from Excel to SPSS. After that, click Analyze, and then descriptive statistics. Click cross tabs. Jenis kelamin move to row. Gaya hidup move to column. Click statistic, and then tick the chi-square. Continue. Click cells. Tick the row and total. Continue. And the last is click OK. Here, incoming data that appear valid are 92 and no one data missing. Next, there is a relation between gender and lifestyle variable where proportion of sex and healthy lifestyle shows that the female gender has a healthy lifestyle with 67.1% compared to men that is equal to 57.9%. Here is the chi-square test. If the value of significant is more than 0.05, there is no significant relation between rows and column or from two observed variables. Otherwise, if the value significant is smaller than 0.05, there is significant relation between rows and column or from two observed variables. Based on the result of the bivariate analysis text between gender variables with a healthy lifestyle, found significant is 0.4452 greater than 0.05. There is no significant relation between two variables.